Okay, so we are recording. Alrighty. Anyway, Java programming practice test 3. I will say interfaces. I have been going crazy with interfaces, trying to know everything and anything about interfaces just because we have a few weird things in his code that don't have the best explanation when it comes to, well, actually exception handling, but we'll get to that when we get to that. So anyway, let me get my notes here. Okay. Okay, here's what I'm gonna try instead before we move on, because I keep losing connection. I'm gonna try to change Wi-Fi networks here. Let's see. Okay. So it looks like it was pretty seamless with the changing. Can you guys still hear me?
Yeah, we can hear you right now.
Okay. Okay, now we shouldn't have any problems for real this time. Anyway, number one. This one seems pretty straightforward. This right here, this is going to be a typical exception right here. Can't divide by 0. Can have exception E. It's going to print out 1. Then we're going to print out the finally block. That's going to be D. Finally blocks are always printed no matter what. Even if there's no exception, this will always happen. Number 2, pretty straightforward. The way you want to think about it, establish an integer x, print out x, which is 1. Do change to 3. This is all kept local though. There's nothing here that indicates that we're returning a value as well. So when we come back here and print, we're going to print a. Maybe later we could try to like mess around with the code to see what we would need to have it print 13. All right, 3. This is actually a more specific version of the earlier question. So you have 1 divided by 0. So it's not going to be a null pointer exception, but it will be an arithmetic exception. So we would print 2, 3. So we'd get, wait, yeah, B on that one. Why do I have E circled on this? B. It's my first time going through. Yeah. Oh, damn. All right. Moving on. This right here, I feel like this is something that he would probably try to switch and change and everything. So it really is just a matter of you knowing how try catch blocks work and how programming works. Because with here, if we try to get the length of a null string, that's just going to be null pointer exception. So we're going to get 1, and then we're going to print 4. And then that's the end of the code. So it's going to be B. This right here, you want to think of it kind of like being unreachable code. Because once you go through once you find an error, you are out of that block. You are not, you're done. Anyway. Next here, this one's actually funny. It's a little bit of a trick question. 0 divided by 1 is not an error. So what happens is it goes through, it checks, nothing's wrong. And then you just go to the finally block, which always exercises when you have a try catch method or block. And then you print 4, 5 as well. So that's going to be D, none of the above. Number 6. This is where the headache starts coming. So by just looking at this, I would assume that this prints out 2-1. But the problem is that there's actually an error in this code, and that's the method signature here. This is supposed to have throws exception inserted kind of right here. I have done a lot of reading about how throw, throws, and thrown is implemented in Java. I don't have an explanation for this, but the code will not run in here. I could quickly type it up unless
Isn't
we
it
have.
because I was gonna say, isn't it because you need a catch with it? So even if you don't have the throws, if you just surround the fun with like a try or catch, it should also work.
Yes, that is very true. And that's kind of what I think actually that's a very good point. That's likely, well, it is probably what it is. Because the thing is, if we were to just kind of type it out, wow, okay, we got a lot of people coming in. Welcome to the call, everyone. By the way, since I have like a bunch of people joining, I'll just kind of re-say this. This is being recorded, so just kind of be careful with saying anything. No, not with saying anything. Like, please chime in, but with what you say. And then also, if we're on number 6 right now, if you have any questions relating earlier things, just let me know. I don't know exactly who it was that added the try catch thing, but that is very true. So if we type this out, right, what we actually get is 2 options. We can either add what you were saying, which is the try catch method, or we can add the throws exception, this right here. Actually, I'll remove this for now just so we can see what happens. Static void fun throws exception. This out. See, so this, the error falls under here. So like you said, we can either surround this with the try catch method. I don't know what code this kind of throws in. I would assume this prints automatically, but this print stack trace, not sure what that refers to. Or you could do the add a throws declaration to the exception. Now, my thought process for throws exception in the method signature is kind of like you're letting the code know, you're letting Java know, hey, I'm going to audit you, and well, my preferred analogy is if I were to come in here and say, I'm sure actually, if I say throw fun or something like that, that's not gonna, would it be like, well, it's not gonna be new fun, is it? Yeah, that's not gonna work. That's a later example, I guess. If I add a throw exception inside of the code, I have to have a throws exception. That way the code knows, hey, we're being audited. So I am creating an artificial failure for the code to think itself and then resolve. But I'm warning the code here with the throws. But someone just left something at our door. What did they? Does Amazon? There's no Amazon. Okay, anyway. That was random. Oh, it is a package. Oh, we just got like a really big package. Okay, anyway. Reasoning for this, I'm not 100% sure. Just keep in mind that if you have a throws exception like this and there's nothing else, like it's like too good to be true, just like pause for a second and give it a good look. Because this right here, this will make or break you.
So you don't need a try catch?
You can. So to make this, you can either have a try catch or you can have a throws exception. They both basically do the same thing in this context. Because if I run this, then we're going to get the 2-1. And then if I were to come back and instead have the throws declaration and I run it, it also prints 2-1. That's why I'm a little bit confused with this one. And I'd say probably for the sake of simplicity, go with the try catch method just because that one seems a little more cut and dry. because when I look at throws, I think, okay, I'm supposed to be catching an exception that I create, and there's nothing here. So what's the point in having one here? So I'm not too keen on it. I'm not too great on that one. So I'd keep an eye out for this. But I like the try catch. I'd say just stick to that, I think. All right, number 7. So we have main, try. So this is actually kind of what we were just talking about. This is surrounded with the try catch method. This will just print 2. This will just print C, I believe. It's not too crazy.
So try block is gonna go anyways.
Huh?
Like the try is gonna, that line's gonna run regardless of an error.
This try is gonna run just fine. There's no error in this here. Okay, hold on. Let's surround this. Let's see. Let me just kind of type this out. Sorry for the background noise. I have family in town, so we're getting ready for dinner on. On this, let me think this through here. Throws exception. Oh, this is, yeah, this is chill. This is just gonna print 2. This isn't that crazy. Any questions on this one? This exception isn't going to print because there's no exception. And that's where well, that's not where my confusion comes from. This throws exception just makes sense. We're trying it, try to catch an exception. It's kind of like we're prototyping it, I guess, but let's see. Anyway, let's move on. I don't hear any objections, so we'll just keep going. Anyway, this one's also pretty straightforward. Call a fun method. Then that's an exception. Comes up, prints 1, prints 2, D, none of the above. Okay, no objections. Next. Anyway, so this is also a theme that you guys will see. It's a little bit of a trick question. Number 9, the way it's going to work, you're going to have your class object. You're creating an object of type class, but you haven't stored anything inside of the object variable. So the way this is going to work is the system will first print. I should be a little careful with how I phrase this. Okay. It's not going to print 1 per se, because the issue is that when you compile, it will crash at this here because there's nothing in your object variable. There's no do nothing method to call. So when you do, that'll crash. The object hasn't been initialized. So it'll be D, none of the above. This code straight up does not work.
That's because like the constructor wasn't finished, correct?
Yeah, if this said my class object equals new my class, and then
Right.
like the parentheses, that would be fine. And I think we actually see that. I think we see that down here actually. No, oh, actually not. Here, we could probably quickly type this out. Boom. Zinga. So this is my class. My God, I cannot type today. Class. Object. This out. Right. One. Object dot do nothing. Boom. This out. Two. So now we remove an extra one of these, and then above the main, add a class. Data. Void. Do nothing. I'm actually going to change this a little bit. That way we know if the void is printing anything. So I'm going to say sys out in the do nothing. So if you see here, yeah, this is going to say, this is going to throw you an error. It's going to say the local variable object may not have been initialized. So if I come here and I say object equals new my class, that's going to solve our issue. So here, let me cut this out first. So this is cut out. If I try to run it, that's not going to work. It's going to throw a bunch of errors, and it actually brought me to the debugger. And then if I come in here, add this, run it, boom. That's what we get. See, so it prints 1, we enter into the do nothing method, and then we come back out, print 2. But that's, keep in mind, that's not obviously not the answer because we have added this right here. Anyway, moving on. Number 10. Number 10 is what I would love to kind of describe as a really great fluff question. This is the Suicide Squad movie of questions in that there's so much unnecessary stuff in it. So you create a my interface class named my interface. You create a my object variable of type my class, and then you call the do nothing method, which when you call this, since you're not calling it of any type of specific class or whatever, inside the main method, you have one. So you print relaxing, and that's the end of your code. A. All right. This is actually kind of where interfacing starts coming into effect as well, because this right here, this interface here is also doing nothing. It's just there. It hasn't been implemented into anything. Let's see. Number 11. 11? This right here, this is actually just what we had been talking about. So we have our main method. We call the do nothing method first thing. Okay, we have that inside of our main method right here. So we print relaxing to the screen. Here's what we can do. We'll have, this will be our little output here, our little notepad. So output. So right now we have printed relaxing. I can zoom this in so you guys can see it better. Apparently I just recently learned you could zoom it in and zoom it out. Okay, anyway. Then it moves on. Yeah, do nothing, prints out relaxing. Now we create a my object variable of type my class, and we filled it. We initialized it with a my class object. Then we get this variable and we say, hey, do the do nothing thing. Go into that method. We come up into the my class, which is implementing the my interface. And then it's going to do public void do nothing. And it's going to print chilling. So this is going to say relaxing, chilling. So I'm right, that's going to be A for us. Yep, A. Okay, we are making time with this as well, if I do say so myself. When we did this yesterday, we were getting hung up on all sorts of little things.
Wait,
Okay.
with that abstract that was commented out, would that code still run or just would it crash? The abstract public void.
Yeah, this isn't really necessary. You see, just because this is implementing here, hold on. Let's mess around with it a little bit. Let's see. I wish I could just copy and paste from the
PDF.
freaking, yeah. Interface. Void. If I'm pretty sure that, because here's the thing, right? So the class is implementing the interface, which means that it has to have the methods that the interface has. Which means that I'm sure that if we were to just comment out my interface, there we go. Comment abstract public void. I can write void do nothing int x. That's commented out. Sys public void do nothing. Boom. Sys out print chilling. Nothing. Boop 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 boop. My class of type my object equals new my class. Boom. My object dot do nothing. And then we come down here, public static void do nothing. Now here, I think one of the fun things that we can mess around with here, if we look at this, right? So this class is implementing the method that's passed into it, not passed into it, but it needs to implement from the interface because we're saying, hey, it's implementing the interface. So we got to have this method in there. That's what this is. So when we call the do nothing method here, I can call in this abstract class. I'm pretty sure abstract method do nothing in time my class can only be defined by an abstract class. Make type my class abstract. Interesting. This isn't really going to do anything if I add a body to it, right? Because I think what would happen is I need to do a little bit more reading up on abstract classes. I'm still a little iffy on them. If the abstract class was uncommented, I'm pretty sure that just wouldn't run. Yeah.
Okay. It just wouldn't run. So then abstract methods only from abstract classes, I'm assuming.
Abstract method. Yes, I'm sorry. I've been calling it a class this whole time. Yes. I believe I want to read a little more into it before I like try to give some kind of exact answer. Here's what I would recommend though. There's a website I use. It's called Java Concept of the Day. I'll send you the link for here. Abstract class. This kind of has like, I'll send this in the chat here. Whoa. So basically, abstract class contains abstract methods, but not all abstract classes have to have abstract methods. Abstract classes and abstract methods are declared using abstract. We cannot create objects in those classes, can create objects to the subclasses of the abstract class, provided they must implement abstract methods. I usually have a few good examples here. See, so this is an example of an abstract class having an abstract method, but we're trying to find abstract method. These are giving more examples of regular methods within an abstract class. or constructors in this case. Highly recommend giving that a read through.
Yeah, man. Thanks.
Yeah. I could definitely see just for the test, he just comes up, deletes that. If that happens, that's just going to be it does not run. That's not going to work. Unless we remove the abstract modifier. In which
I think
case,
you can probably add
Yeah, yeah.
abstract to the class because you can have abstract and implement an interface, correct?
yeah, we actually see a little bit of that later, but let's see abstract class. That looks like it. Oh, throws in cannot instantiate the type my class. It looks like that doesn't play along too well with the creation of the object. Which makes sense because I when I look at abstract, I look at abstract as kind of like the foundation to a house. The abstract contains methods that you can then extend into subclasses, and the subclasses implement those methods. They write them out, they do things with them. Whereas with the abstract, kind of like with interfaces, you just have it, you know? Okay.
Quick question.
Yeah.
Does the sum arguments portion, does that like really impact the code? Where it says like string brackets sum arguments?
This right here,
Yeah.
that oh, do you think it's like affecting like our code here, like in terms of what we
No,
have
I'm
here?
just wondering because I just saw that and I was like, oh, it's different from the RGS part, so or
Oh no,
ARGS.
this just
That means arguments too, right?
pretty sure. Let's do it. Let's try some. Yeah, there you go. I guess it
Okay,
yeah,
cool.
this
Awesome.
is
Thank you.
okay. Yeah. I've it's funny, like you mentioned that. Like I noticed that every once in a while, but I've never really thought too much about it.
Yeah, I just
All
picked
right.
it up every few questions.
Yeah, fair. All right, let's see. Number 12 though. So number 12. I think number 12 is actually a pretty good example of a fluff question. So we create a my object variable of type my class, and inside of it, we instantiate a new class, a new my class. And then we say, hey, my object dot do nothing method. So we come up here, and then we look at the class. My class implements my interface. So we've implemented the interface here, and we just print out chilling. Answer is B. This is kind of what I didn't get to see whose name it was, but here we do have an abstract class which implements the my interface, but this is not really doing anything. Now I'm pretty sure that if we had this say class my class extends my abstract, I'm pretty sure we would have to implement, not implement, but like pass through the same method. Let's see, do I have the, let me see if I can find anything like that here. Yeah, see, so, well, at least in this example, abstracts use separation from them. Yeah, abstract in Java is used to define only ideas in one class so that the idea can be implemented by its subclasses according to their requirements. So here we have an abstract class, and it has an abstract void thing here that says, hey, sound of the animal. We have a cat. And then we're kind of implementing the method from the abstract class. And then we're saying, hey, the sound of the animal cat in this instance is male. Male. And the dog says bow bow. What the hell is this website? Okay. Anyway. Do we have another example of this? Yeah, here we have abstract class with the abstract method, and we have a concrete class which extends abstract class, and here we have this method. Now, one question I do kind of have is, can we add, like here, let's see, I'm pretty sure is this allowed is what I'm wondering. So here's what I'm going to do. For the sake of practice and science, we're going to delete that. I think we could actually just copy and paste this straight up. Let me just leave this up here. So this, the type cat must implement the inherited abstract method. Yeah, so it has to be in a kind of like an exact implementation.
Signature's got to be the same.
Yeah, exactly. All right, let's see. Number 13. I'll let you guys read this through and let me know if anything catches your eye here. It's a little bit. Wait, didn't we just do 13?
No, we did 12.
Oh. Let me know if you see notice anything different with this one. Let's see.
It's a class trying to extend the class.
Yeah. Even if this was changed to my abstract, how do we think that would change things? Let's see.
It wouldn't work, right? Because of like looping.
Yeah,
you
this
mentioned
would
something
kind
about
of
looping.
this would kind of give you an error. My notes here, I just have it says like even if it said my abstract, it would not work. Here, get my extended notes here. Number 13. Yeah, my notes just say it's just continued. Okay. Number 14. This one's a little bit of a trick question, so I'll let you guys give it a look over. Let's see.
Does this give us like a null pointer error?
Yeah, this would be a null pointer error to be specific. Oh, Alan is waiting on us to let him in. Welcome. Let's see. Welcome to the call, Alan. Yes, this would be a null pointer exception. Welcome to the call, Alan. We're on number 14 of the practice test. This is being recorded. If you got any questions about earlier stuff, let us know. Let's see.
So,
oh, sorry.
Go ahead.
Oh, yeah. I was going to ask, how's there a null pointer exception? I kind of see it, but need more clarification.
Yeah. So what you really want to look into is, although we have created an array of type my class, and we said, hey, we have a my class, we have 3 spots inside of this array, but though it's an empty array. Understand? So the way I like to think about it is, in this instance, you have like a shelf. Let's see, let me open a whiteboard here. If it'll load. Is it loaded? Oh wait. The way you want to think of it, here's how I like to think of it. So you have an array with 3 little spots in it, right? And what we did in the code here, can I really not just like drag a window? Oh my God. I have too many things here. Okay. So we did. Oh my God. Come on, let me move. Okay. This right here, this array is of type my class. But these are empty, right? So imagine this right here is saying, I have 3 of those like shelf cubicles, right? And I tell you, this is my Lego set cubicle shelf. And that's what I'm doing here. You know, so I have my cubicle shelf and it's for my Lego sets, and I have 3 spots. right? So what happens is if I say to you, in this instance right here, this is where the error occurs. Get me the minifigure of my Lego set in the first box. There is no Lego set in here yet. So if I try to pull, if I try to look for one, there's not going to be anything. That's going to be a null pointer exception. There is no data there to be pulled. So this was going to print bug, and let's look at the next question, because this kind of it expands on this earlier question. So the only difference between 14 and 15 is this line of code right here. In the for loop, we are iterating through each cubicle, each spot in the array, and adding a new my class. So in this, we are putting information inside of here, and we're saying, hey, this has a Lego set, and then this has a Lego set, and the my class all have the int data in here as well. So we have a data that we can call. I'm a very visual person, so Lego sets is perfect for me on this one,
Yeah, that's simple unless you work. That worked.
Yep. So in this instance, when I say, hey, get the data, I got data right there. See? Okay, moving on. Okay. So I say we did 14 and 15 in one go. Should we just go on to 16? I think. This one's I hate this one. Okay. Number 16. The bane of my existence. If we look at this bad boy, what we want to look here is we're going to throw an exception here of type my class. Then what's going to happen is when that happens, let me look at my notes here. Wait, is this right here? Okay. This is a pretty good example of my grenade analogy from earlier. And also this has also been the source of a little bit of confusion I've had with the whole throws or even just creating classes. But here's kind of what's happening. Yes, please let me screenshot. Let's see. Okay, it's not popping up, but what if yes, perfect. Okay, this is what we're gonna do. We're gonna read through. Throw new class. This is me telling you I'm throwing a grenade into your code. The act of throwing it. When I create this new class error, what's going to happen is this gets created. This entire class up here gets created. Now, what we want to consider is that data is started out as 0, but then gets incremented to 1. So data by default here is going to be equal to 1. Now, the thing is, we are inside of this class right now by having done this. So what's going to happen is then it just defaults to the toString method, because the toString is kind of like a default Java method that gets put into just about every class. And then it prints space 1. And that's how the cookie crumbles. It's a little funky and there's a few leaps of logic to understand it, but it's there. It exists, it's real. I don't hear any objections, so we'll just keep going.
Wait, is it printing out 1 or 2?
One.
Oh,
It's printing out one.
the,
Where are you getting two from out of curiosity?
the catch. The catch doesn't go anywhere. Oh, because there's no error. Okay, never mind.
Yeah, catch. That's kind of where my main confusion is with this, because I'm saying throw new class. And to me, throw has been kind of like the intentionally throwing in a problematic piece of code. So in my logic, this would print E. Like, I think it would print this sometimes, but I also understand the whole, we have created this new class, we're in here, we increment the data, and then we return the data and print it. You know,
Throw, I think, like forcefully makes you go through the whole like my class thing, and then after that you also have to execute the catch portion, because I think there's another question that has you do that, and it explains why the result is it's because you have to go through my class and then you have to go through the second time when it's caught.
would that, you know, that would be a pretty good explanation. Let's just quickly type this bad boy out then. Let's see. I know we don't want to be wasting too much time on typing, but let's see. Let's just minimize this. Okay. Try throw new my class. Did I really just write try and then just like not even like? Okay. Wait, what? Oh, wait a minute. No? Oh my God, I'm having deja vu flashbacks from. Literally, I was having the same issue yesterday. Hold on, try. Open, throw, new, close. Oh, I have two closing ones. Boom. There we go. So it's right here. This is going to print one. And if I add here stuff, the nano one, we'll see it that it goes to that two string. Now you saying that throw forces it to go through, maybe not through the whole class, but at least enough to go through the main method, increment the data, and then go to the two string. I kind of believe you.
Yeah, because I think one of the other ones, it's like the int you have in my class is set to static, so obviously once you change it, it's like changed forever, and I think it increments 2 times because of like the throw and the catch. I think there's another question, so it'll better. I think it's like number 17. It'll better.
Yeah, that
explain
is
it.
another question. I know
Yeah, 'cause
exactly what you're talking about.
Exactly. So that's kind of how I see throws, because I think I used it in one of my codes, but it'll forcefully essentially like execute it.
Interesting. Okay. I had that one explained to me though as each time like it's all pointing to the same object as opposed to having its own object. Now I'm not too sure about how truthful that is, but your logic makes sense as well. So I will take both into consideration and see if I can find anything else regarding it later after this maybe. Anyway, down here, number 17, main. So here we have my class dot data. This is this is the one you were talking about, I think. This is what you're talking about. Because look, here we're saying, hey, my
Yeah.
class data is equal to 1. Then we increment it, so now it's 2. And then we throw new class. And then by doing that, like you said, now increments again, now it's 3. And then since it's throw, it also goes to the toString, so it prints 3. There is no error in 17. And yeah, and the answer is C for that one. So here's what I kind of want to do though. I want to put that to the test a little bit. Here's what I'm thinking. So how much does this change? Like you said, so this, does this have to be public static here? Is my first question. Then data, return data. This down here. Actually. So this prints banana 3. If I copy this, I paste it. Is this going to print banana 4? Oh, wait a minute. Unreachable code. Okay. Let's say we do my class, and I say Miguel equals new my class, I guess. Now will that print 4? Mother of God, it prints 4. Okay. Second question. What if we remove the static? Oh. Cannot make a static reference to the non-static field. Interesting. Okay, yeah, because what you were saying is if we make it static, we're putting the number 1 in that variable and it stays as that. Okay. Stays like that. And it only gets incremented when we call it. Gotcha. That makes sense. Okay. Number 18. This one's a fun one because it's easy. Create a new test string. It's equal to test1. Say, hey, change class and then pass through test. Come up here, pass through test. Test is equal to test2. Come back, system.out.print, print test. And your answer is B, test1. The reason being that the change class method does not return anything, and the changing of the class is kept local to the class. So it doesn't change anything with test in the main method. Okay, continuing on. Class change. Okay, now this one's the continuation. Change class dot test equals test1. Change class dot change. So actually, if we look, this right here has nothing to do with this line right here. All we're doing here is we're saying, okay, we're going into the change class method. We have a string called test, and then we're going into this change method that sets test equal to test2. So then down here where we say, okay, let's go back into the change class and print out the test variable. So we come up here, test2 has already been set, or test has already been set equal to test2. So when we print this, that's going to be B. We're directly accessing the local variable within the change class.
So if you were to take out the change, would it just like come into an error?
Which change? This one right here?
Yeah, if you took that out, would it just like read an error?
Yes, just because like just in terms of how you have to write Java, if I'm doing dot change, it has to be coming from something. So if I were to, okay, let's mess around with it. Let's see.
Because I think it's what they're both named the same, change class dot test.
Yeah, I get that. Okay, let's see. Well, yeah, okay, actually, no, I'm gonna walk back something I said earlier. This right here, you're right, this does go into here. It gets stored into this test variable in the change class. So here, let's just kind of get this written out and then we can mess around with it. I can type public. My God, public. Oh, wait. So I'm sure actually, here's what we can do. Here's my menu. So if I run this is going to print test2 right here. Now, if I were to do this, where I say, here, I am printing test before the change. So now this should, in theory, print test1, test2. Boom, there you go. Because
Gotcha, makes sense.
Yep, here we're storing test1 into the test variable. Then we're printing it, then we're changing it. We're coming up here, we're setting the test variable equal to test2, and we're printing that as well. Okay. To whoever called me out on that, thank you, because I would have kept running with it. Okay, 20. So here's where, I don't know who was saying that earlier, where the throws word makes the program run through the class, because with this, when we create the new test class, it prints test. There's no exception. So we exit the catch block and then we come out here and we print test again. Answer is B on this one. I think just the class, just having a two-string method, maybe that changes something. We could kind of mess around with it a little bit, maybe. Give me a quick second. Alrighty, and then we're gonna say catch exception T. And then here we have sys out T test. Now here's what I'm thinking, right? We're gonna have a test. Then we'll come here. We're gonna have, if we just have a public toString. Method. That's obviously just gonna print test. Yep. Oh, I like how it kind of pops up like that. Question. Here's where I'm coming from now. Public. Do another method here. It's gonna called Bananarama. And what this is gonna do is this is also gonna print. But oh, that needs to be a return statement. Okay. Boom. Now that doesn't print but. You see, that's what confuses me there. We are just defaulting to the Java default method toString when we I think the word is instantiate a new test class right here. Because if I were to, what if I were to come here and say new test? Is that allowed? That's not allowed. Okay, what if I say test equals new test? Boom. Would this in theory print test? This would print test. No. Interesting.
I think it's because like the toString is like an override of some sort. So whenever you want to print out that whole like class, if you just put like print out class, it's only going to print out what's returned to that toString.
Yeah, I think you're okay. Let's just do, I'm just gonna try one more thing. What if I come here and I say print? Oh, actually, I'm overthinking this. Think about what we're doing here. I'm saying, hey, print out the new test class. The default method in Java for like returning a string or printing is toString. I'm way overthinking this. So this right here, we can comment this out. This should in theory print test. We got it, boys. We got it figured out. We see through Java's games. We understand now. At least I understand. I don't know about you guys, but when we say to Java, print out test with this right, we're saying, hey, print it out. We go into this like, oh my God, what do we print? Java says, hey, we've got something for that. toString. Let's print that. Let's return it. That's why we get test. Duh. Oh my gosh. I need to lay off the coffee. It makes me overthink things. Oh my goodness. Okay. I hated this one. This actually is a pretty good example of one of the most important things about interfaces that we talked about in class. Interfaces are always, if I'm correct, public, static, and final. So what happens is that with this here, we have an interface called iParent. And in there we have a public integer x is set equal to 1. So here's what happens. In the main class, we create a new class child, and that comes down here. Now, where the error is this class child is implementing the iParent interface, which means we have to use both of these things in the class. So we see we have a print method right here, and the x is here, but that is set equal to a, which in this instance, it is 1, but it's not 1. you know, like they're this technically the same, but they are different. You can't change the value of X. So your error is going to stem from this right here. This code will not run. This is D. None of the above. Now, I would be careful with this question because in class, one thing that we did do was we had someone come in and reestablish the private X integer. And I think the code worked for him. I'm not entirely sure. But with that, it's weird because you're technically overwriting the X within the class, the child class, which doesn't make much sense because you have to implement X as it's given from the interface. Now we could type it out. This is just a lot to type is the thing. Let's see. If we're feeling it. If anyone doesn't want me to type it out, please object. You know. Oh my God.
So with private and what about the keyword this? Would that change anything?
Let's mess with it. Let's see. I'm thinking the this. You're saying putting a this dot x here. Where the x equals a, is that what you're saying?
Yeah, we're saying yeah, this X instead of that X. Like, would that change anything?
I think you would. I'm shooting from the hip here, so we're gonna test it out. But I think that the issue with that is that X is never instantiated within the child class, right? So let's see. X equals 1.
Oh yeah, you're right. It's never instantiated. Okay, I see what you're talking about.
So this is where our error comes here. It says X is equal to A. The final field parent iParent dot X cannot be assigned. So if I come here and I say private int X, the value of the field child dot X is not used. So I'm just going to say plus X. So this should print child 2 1. Yeah. Interesting. So it looks like we grab the X, we bring it in here and we overwrite it. We're basically like money laundering the X variable here is what we're doing. Because if we did not have this, X is being directly passed through as the variable from iParent, from this up here. But I guess we can just directly pass through X, money launder it, and then it works, which is kind of odd. So if we have private X here, and then let's just remove here, we're not using X at all. It's going to give us a bit of an issue, but not too bad. Child 2. Be careful with that on the exam. I could definitely see this being something that he does.
So that X can be changed once it's private. So you override it?
Not necessarily that it's private. It's just that when we just do this, we're directly, I like to think of it as we're directly passing this into the child class. But you can't change the value of it because this is also final, public integer final. But if I come into here and I say, hey, I'm passing through the X and then I'm making it private int X, you're like money laundering it and then you can change it. Like suddenly it's okay, you know?
So it's the same variable, not two different variables, correct?
They are. Well, okay, here, let's change this value here, right? Let's change child, let's change that to 69 for it, right? And if we run that, well, actually, wait, that's not, we're not gonna see any difference here. Plus, let's just do plus X. 269, yeah, so the value has changed. Now here's. I can't just do sys out here, right? I'm trying to like muscle things through like I do in C. Yeah, it's not gonna work. Okay. Oh, what if we do this? Hold on. Maybe. Yeah,
It's just a different
so
X. It's a different X.
so this right here is because what if I do 5? So now this should print 5. Yeah, we've money laundered it basically.
¿Y qué hago con mi orina? Su orina no tengo tiempo. Oiga, me guarda un poco de ese veneno para ratas. Pero no es urgente.
Okay, let's see.
Sí, sí, cariño, es hora de tu paseo.
Anyway, that was a fun one. Okay. 22. I mean, we're almost done. Look at us. Okay. This is kind of an example, I think, of the stuff earlier.
Quizá yo me contagié también. Los vecinos tienen miedo. ¿Dónde está su mujer? En el hospital.
Create new parent array, new iParent to try. This is going to be an exception. That's just going to print bad. This is, and all this is stupid. All this has no point in being here. This is kind of like the example we had earlier. Keep in mind, this is an empty array. You know. Okay. 23. Recursion. I love recursion. How fun. How fun. I love it. So do we have any guesses on this one? And the why? I'm still streaming my screen here, right? Yeah, okay. Great
The
guesses.
second return statement will execute, right?
Yeah, so this is there is no errors in this. This is gonna work. It's just a matter of what is our output gonna be. Oh, I didn't see the chat. Yep, you guys got it. Does anyone have any questions on how it is that recursion might work? I will say recursion is a pretty big thing in CS1. And I'll admit it's a bit of a headache. It's a bit of a lot to wrap your head around, you know. So I don't hear any objections, so I guess we'll just kind of keep going. All righty, we're muscling through. We are making time, ladies and gentlemen. We're making time. All right, 24, the big one. So this one is actually quite fun. Because where's my notes here? I have quite some extensive notes on this one. So this is a really good example of the conversation we had earlier. Because this code alone, as it is right now, just prints done. Totally fine. Here's why. Try, we have our main method. We have a try block. We pass through the number 65, gets brought up into the fun. Here, actually, I love drawing. So let's do this. So this 65, if it'll let me freaking write, okay. This 65 gets passed through up here. 65 is not smaller than 0. I'm sure we can all agree on that. Stay quiet if you think it is smaller than 0. Weirdos. All right, anyway. It's because 65 is not fulfilling this condition. The throw my exception does not get called. So nothing really happens. We return back down here. We print done. We exit the try catch block. There's nothing left. That's it. That's the end of the program. Now, where most of my notes come from is what if we, and because this is something he could very well do, what if instead of fun 65, he puts in fun -1? Because the thing is, if it was -1, we pass it through up here into the top, and -1 is in fact less than 0, which means it would execute this code right here. However, if you do this, well, I think in general, you actually do get an error, a little bit of an error right here, because it should still, actually, let me write this out. I want to make sure I have this all written out before I say
Oh, the
anything.
method.
Okay. So we got main, and this is all within some guy in the group. He goes, "Did I miss it?" Not necessarily, I guess. You should try joining. Oh, wait. I'm sorry. I messed up. This goes up here. Boom. I can type. Okay. It goes there. Now in the public here, we say try on 65. So, yeah. Wait, this goes age plus is valid. My God. Okay. Okay, so actually, I was wrong. Before we even changed the 65, I must have forgotten. This is already giving us an exception. Oh, actually, you know why? Because this right here should say with the capital M. The whole thing is giving us an issue. Because we have to add the throws declaration. So we can either, if I'm right with this one, we can either add the throws declaration or, oh, maybe we can. Oh, this needs a condition. Done. Okay. Now, if this is -1, but done. Aha. Okay. I don't know who the person is that was talking about the try-catch blocks earlier, as opposed to having the throws exception. I didn't catch her name, but what we can take into consideration here is here we're passing through -1. We pass through -1. That's going to activate the throw new exception. Now, you can have it as a try-catch block, or you can also have it here, throws exception. This is, you can have, oh, Adrian's trying to join. Okay, welcome to the call, Adrian. This is being recorded, by the way. We are on number 24. If you have any questions regarding earlier questions, just let me know. I'm just quickly explaining this, and then we could kind of regroup and everything. As I was saying, though, try catch when you're throwing an exception, this right here, when you're throwing a grenade into your code, you have to tell your code that you're throwing a grenade into it. So you can let it know one of two ways. You could do what our friend earlier was mentioning, having a try catch block, which is 100% valid. And then, or you can also have throws exception in the method signature, which is also valid. They are both achieving kind of the same thing. Now, I'm pretty sure, now let's do this. Let's comment this out right there. Comment that out. Comment this out. That way it just keeps throws exception. I'm pretty sure that what'll happen. Can we take a guess? Does anyone want to take a guess before we do this? What it's going to do? Because I'm actually not sure what's going to happen. Okay, don't all jump up at once. But what I'm assuming is that we are going to end up in the catch block here. So I'll put here in the catch block. Because this is going to throw an exception. The code is going to recognize that. And then it'll come back and then it'll say, hey, this is an exception. So it won't even print done. It'll just print in the catch block and then our error message. That's what I'm thinking.
Yeah, it's going to catch it.
Boom. In the catch block, -1 is invalid. Boom. Thank you to whoever also chimed in. Seems pretty straightforward. So basically the way I like to think about it is you might also, well, actually, you might also think to yourself, Miguel, why is it that with, for example, number 8, if we go back and look at that one, why is it that when we were doing that question, we did have an exception inside of the method call, but we didn't have any kinds of throws or catches in here, number 8. Fun. You have an exception here. There's no kinds of catch exceptions or whatchamacallit. What's the string again that I throw it? There's no throws methods. There's nothing. You have an error here, and then it correctly catches it. No questions asked. And this is why I think that, at least in our case, it is so important to have that analogy in mind. In this instance, you're having like a real life kind of exception that's happening. You know, this is an actual grenade that is being thrown, and your code is manages to catch it. Now, what happens is, think of it like, you know, in like Doctor Strange's mirror dimension. When we start adding throws, we're artificially creating an error where we tell the program, throw again. This is like I'm throwing a grenade and then saying throws exception. I'm telling my code, I'm gonna throw a grenade, and then your code has to know, okay, I'm gonna have to catch it and then deal with it. So this is almost like you're auditing your code versus having a real life situation. You can't have it in between, you know. So that's how that works. And I'm pretty sure that if I were to just have instead, if I were to just let's comment this out. I'm pretty sure that if I were to just say throws, well, actually, if I do a throws within the try block, that's doing the same thing. I don't need to do anything with that one. And actually, come to think of it, this main also has a throws exception that we didn't have earlier. If I had an exception here, like an let's say throws new my exception, and then I guess I'll say age here as well, and then beforehand I'll just come over here and say int age equals 420. Is that gonna work? Wait, that's not right. Exception. Syntax error token throws. Oh, wait. This is going to be unreachable code, which is fine. So in this instance, so this unreachable code is actually an error. It's actually an issue, apparently. In the catch block, yeah, see, so it also catches it here. Yeah, okay. And that's 24.
So wait, the method, private static void fun doesn't have an exception. It still catches it?
No, what I did here, I just added an exception here. What I can do is I could change this with whatever here, banana, and then I'll uncomment that. Well, so if this does not have an error, right, where I come here and I say, like, I have my throws exception in place, meaning that my code is looking for a grenade. And I say, hey, 65, and I run it, I'm going to be under the impression that we're going to run, nothing's going to happen here, which is fine. And then we're going to print banana done, and then that's it. Yep.
Yeah, but so you know where, what was that, line 5? There's those exceptions. If you remove it, it'll still be caught, correct?
No, if I remove it, the code won't work. Because, like, imagine this, right? Imagine you're like a security guard and I throw a grenade at you. It's not going to be a fun time, right? And then afterwards I tell you, oh, I was auditing you, like I was testing you. You're probably going to be mad at me. Now, if I come to you and I say, hey, I'm going to audit you, I'm going to throw a grenade at you, you might be a little frustrated, but you're not going to be like pissed off with me. If I remove, even if this never gets called, because here I'm passing through 65, which is not less than 0, I still need to have a throws exception in here. That way the code can run. So here, look, let me show you. If I have this, I delete it. This is basically number 24 in plain. If I run this, proceed, I'm going to get an error because I have unresolved compilation problem. Unhandled exception type, my exception. See, I didn't handle this grenade throw, or potential grenade throw. See, because in this instance, we didn't throw it. But if we did, the code would have not had, I mean, here, let's try changing. Let's see. Would changing it do anything? Let's see. No, that doesn't work either. So in this case, I am killing my code, basically. Yeah, now that one.
I got it. So if we're it's like our own error checking, we have to catch it.
Yeah. Yeah, definitely. Basically, think of it like this. If you're throwing something, you're either going to have a try catch block, or you're going to have a what's it called? Throws exception. You got to have either or. You can have both of them. You could do that. That's allowed. You could come in here and you could have both of them. It's redundant because they both do the same thing. But if we have that, we come through the exception, but banana, done. In this instance, because it's -1, we did go into the catch block here. You see right here. So -1 comes in here. So it prints out, but comes back, prints banana, and then
Why not invalid? The my exception class extends exceptions. How come it doesn't print invalid?
because here we can do that. We can say, if there is an exception, we can say sys out my exception, and then I can say age. Why is that not wanting to work? This method of exception is undefined for the type main banana. Hold on, let me think of this. Dot age? That's the wrong way of doing this. How do I wait? Hold on. I'm trying to remember how to put the reason we're not going into my exceptions because the way I had this written earlier where it says but there's nothing getting us into this class. Although there is, I can't think of how to do it now for some reason, but if I were to say this out, I could say my exception. Damn, I'm actually at a loss for this one. My exception age. It should that should work. I'll figure it out. If anything, I'll let you guys know what I get in the Discord. But
All right. So nothing gets us into that. That's just nothing, right? That class, my exception, just nothing.
Yeah, in terms of how I have this all written out, there's nothing getting us into this class right here. Now you can have kind of like the, let me see if I can find from an earlier example. Where is it? Need some inspiration here. What if I come in here and I say, close. We'll figure it out. But yeah, there's nothing getting us into that.
I think like number 17. I mean, that's close to it. Like my class extends exceptions.
Yeah. This right here, that would just print. I just can't think of how to call the my class number. But essentially, do we understand at least the basic concepts of 24 here is for why that's doing what it does?
Yeah, I got it.
All right, far out. Does anyone have any other questions regarding practice test 2 that we could review together?
Just a quick one. For number 2, how would you print 13? Like, I know you had said something about wrapper classes, but yeah, can we just like go over that?
Yeah. Number 2 in X, press 1. All right, let's get this bad boy typed out. So here I have int x equals 1. X. Then we go to a separate method, public void change to 3 int x equals 3. So this right here, this is going to print 1. Best way I could think of this would probably be, we could say like print change to 3.x perhaps, but that doesn't even have a stored value. So that's probably not going to work.
No, we would have to wrap it. I'm not sure how to wrap that.
Wrapping is something that I have also not looked too far into.
I know we have to create our own class of wrapping. So like you would have to add a whole nother class.
Could we do like a return type? Like we could say maybe that's probably my best bet there. Return type to integer. I could say x is equal to that maybe. Aha. I got it to print 13. There you go. What if I don't have a return method here? That would just print 1 because we're having an error here. Yeah, so you do have to have a return. So return x. That way that like regurgitates it into this. And then it's like, oh, x is equal to that. Awesome. So that's how you would do that. That's a good question because that could totally be something he does. You never know.
No, thanks for going with that.
Of course. Does anyone else have any questions by any chance? I know we're coming up at 9. We've been going at this for a pretty good amount of time. No. Well, if you got any questions, feel free to DM me on Discord or group me. I'm going to be studying here just about the rest of the night. Because we want to pass this test. So that's where it's going to be. Alrighty though. If you guys got nothing, or if you want some time to look through the test, ask a few questions, let me know. But if anything, I think we could probably end it here. So let's see, let's turn off the screen sharing. Okay. I wish I could see how long the call had been going on for already, but we'll figure it out. Alrighty, I'll give you guys a couple minutes to see if you guys got any questions and then just let me know.
I'm all good, but thank you so much. Really appreciate it.
Alrighty, of course. Have a good night.
Thank
Yeah,
you.
man,
Too.
thanks.
Good luck tomorrow.
All right. Good night, guys. Good luck. Good luck. Alrighty. I'm gonna stop recording here and then we could